imagine that most of you were where I was this morning watching the keynote with Scott Davis. I know it isn't directly relevant to what we're going to be talking about, but I want to show you something. When, most of these AI tools you may have noticed all cost you like between $10 and $20 a month. All these subscription services. Well, I got an ad like 6 months ago for another tool, and I thought I'd try it out because they gave me some free credits. And my conclusion was it wasn't worth the money, but it was kind of fun to play with. So what I did, and this is what I just thought I'd show you, is I took one of my YouTube shorts, and of course it was in English because that's what I know, and I uploaded it to this site called Heygen, Heygen. Anybody heard of it? Yeah, it's very expensive, but I tried it. And like I said, I had free credits. And it translated the audio to another language, but not just that. It changed the way my mouth moved to make it look like I speak that language. Okay? So let me just show you what this looks like. And I couldn't get the audio to go through the system, so I'll just play it right now on my speakers as loud as I could make them. And if you're laughing at the Hindi, then I get it. Okay, no problem.
तो 60 सेकंड में मखितो जासूसों के रहस्यों का पर्दाफाश करने के लिए स्पाई मास्टर में आपका स्वागत। मखितो स्पाई क्या है? रहस्य का पर्दाफाश करे। मखितो जासूसी का
It's only a minute long.
उनके संवादों की पुष्टि करने के लिए मेरे पास एक कक्षा है जिसमें एक लॉगर है, विधि का परीक्षण करना है जो नहीं लौट आती है। चीज का परीक्षण कैसे करते हैं? कुछ वापस नहीं आ रहा। तुम क्या करते हो? और मैं इस टेस्ट में लॉगर को एक जासूसी में लपेटे। जब आप इस विधि को कॉल करते हैं तो आप संदेश को जासूस को भेजा गया था कि जानकारी संदेश सत्यापित कर सकते हैं। यह अधिक विवरण और समान वीडियो के लिए टेल्स फ्रॉम द अदर साइड यूट्यूब चैनल की सदस्यता जरूर करें। बहुत धन्यवाद।
I understood Tales from the Jar Side. I got that part. Any rate, when I made that, I sent it to Dilip, of course. I'm thinking, I know lots of Indian developers, of course, but I sent it to Dilip and said, okay, how bad is this? And he sent back basically what you did. He was laughing. He said but what I learned from this, because I also did one in Polish and I did one in Dutch, I think, something like that, and sent it to people, and they all basically had the same opinion. They're like, we're more accustomed to dealing with accented English than bad Hindi, So, okay, thanks, but don't do that. So when Scott was talking about his automatic translators and using AI and everything, that was considered state of the art, and they didn't want $20 a month, they wanted $40 a month. And I'm like, yeah, no, I'm not going to do that. But I knew you were the target audience. And on my Tales from the Jar Side channel, my second largest audience is from India. So I've always felt a connection here. I'm always happy to come here. So what I want to talk to you about actually is accessing AI tools as though they were simple RESTful web services. And I want to access them without using a framework. Now, the frameworks are coming. Spring AI looks very promising. LangChain for J, I think, is already usable. But they're both limited and they're both under constant development. Neither one of them is at version 1.0 yet. So I don't want to commit to the details of those because it'd be like, what if it all changes in 6 months, And you know how much these things change under that. The other reason I'm not committing to a framework right now is that the frameworks don't cover all the use cases I want to do, whereas most of these AI services provide a RESTful endpoint that does lots of things. And if it isn't considered a high priority for the framework, that would mean I can't do it until they incorporate it into the framework. And I'm like, hey, it's a REST API. If there's one thing Java developers know how to do, it's connect to REST APIs. So yesterday, I did a bit of a talk about using like Java's HTTP client and using the Google JSON parser to interact with RESTful web services. Today, I'm going to do something similar with different examples and things, where this time I'm going to take advantage of all the neat tools that come with the Spring framework. I don't want to do that in general because it cuts down the audience to only people who are familiar with the Spring framework. But if you're a Java developer, it's really hard not to run into the Spring framework sooner or later, you know? So that's why I separated it out into a separate talk, but that's the actual goal. That's what I want to show you here. Now, for those who are interested, there's my contact information. I'll have that again at the end, and you're welcome to contact me. I don't have a LinkedIn link on there, but just search for me on LinkedIn. There are not many people with my last name spelled that way. It's pronounced Kousen, by the way, like the relative. It just doesn't look like it. We think it was messed up on immigration somehow, you know. Yeah, so there's my email address, homepage, blog. I still have a Twitter handle, although I don't use it so much. I'm on Mastodon. I have my free weekly newsletter, comes out every Sunday, called Tales from the Jar Side. This week's going to be tough, but we'll see. And that short was on my YouTube channel, which is called @Tales from the Jar Side. Okay, those are the books I've written in the past. The QR code, by the way, takes you to the YouTube channel, just in case you're curious. Okay, now, OpenAI is one of the ones I do want to talk about, because OpenAI, of course, was the first one to break through and become available in the popular press. If you go directly to chat.openai.com, that's just regular ChatGPT. And in order to use GPT-4 and a lot of the other tools, you have to pay your $20 a month. Well, the thing is, if you want to be a developer and incorporate these AI tools into your code, which is what I'm after, then it doesn't matter whether you have a ChatGPT subscription or not. That $20 a month is completely independent. In other words, you don't need it if you just want to be a developer. Frankly, one of the other ones I'm going to talk about is Claude from Anthropic. They too want $20 a month. I don't pay them. I access them through the API, and it's all pay as you go when you do that. So for all of these services, when you access them programmatically, it's all based on tokens that you input and what you get back. And in fact, since there were some questions yesterday, I'm going to show you the pricing page, give you an idea what these things look like. Now, of course, the pricing page will be in dollars, but I trust you to have a feel for how you would convert that. In any case, what you have to do, and at OpenAI, it's at platform.openai.com, then you have to register and get a key. And the only way you can get a key, well, not the only way. You register and get a key, and then you add your credit card, because you'll be very limited until you do that. They even say there, oh yeah, we'll give you X number of dollars for startup, and that never worked. I mean, that might have worked the first month they said it, but it's long gone. It didn't work for me when I did it a year ago, you know? So they want a credit card. The good news is that the prices are very, very low if all you're doing is working for yourself and just experimenting. The costs add up if you put it in production and you have thousands or tens of thousands of users and you're using it all the time. But if you're just doing it by yourself, you'd be hard-pressed to spend $1. It would be hard to spend a whole dollar on this. I mean, I expect that all the prep I've done this month, I doubt I've spent more than 50 cents, you know, probably less than that. Now, for those people who are worried about sending any data to a cloud provider or whatever, I'll have a bit at the end about Ollama, which allows you to run on your own machine and still provides an API, okay? So with OpenAI, again, actually with any of these, the idea is you figure out what the input message needs to be and what the output response looks like, and you map that to records. Now, yesterday I did a little demo where I showed how I use sealed interfaces to make that uniform and everything. You don't need to go to all that trouble. You can just build records. And the beautiful thing about records is you can nest them all you want, one record inside another record and however you want, and then refactor them later to make them independent top-level classes if that's what you choose to do. One of the ones I want to start with now is I want to go to, let me show you the pricing model real quick, just so you have that available. It's at openai.com/pricing, and I think I'll close that now. This is that pricing page. I know that this room's kind of awkward seeing from the sides, but I can tell you what's in here. So if you scroll down, their flagship model is called GPT-4 Turbo. And believe it or not, GPT-4 Turbo is less expensive than GPT-4. which is weird, but okay, that's how it's set up. And the number to remember is this one. It's $10 per million tokens, which works out to 1 penny per 1,000 tokens. And there's input tokens and there's output tokens, and output tokens always cost more, either double or triple, depending on the API. But the output tokens are what the model is sending back, and you can always set a limit on how many you want back. Usually I don't bother, but you can. Input tokens, though, that includes the system message, user message you're sending in, any assistant messages you received previously, if you want to build up a whole conversation. You know, you get this whole big thing in there. But again, I mean, how much is that? Well, 1,000 tokens is roughly 750 words on average, English words. So, I mean, a typical request is what, 100 to 200 tokens at the most? Even if I have a system message in there and more, I'm going to be hard pressed. I'm not going to get anywhere near 1,000 tokens. Remember, 1,000 tokens is 1 cent. You know, we're not talking a lot of money here. Again, if it's in production, then okay, maybe if you're paying for all the accesses, that could add up. But that's to give you a feel for what the numbers are like. Now, if I scroll down, GPT 3.5 Turbo cuts that number by a factor of 20. So it's not 1 cent, it's 0.05. Actually, it's 50 cents per million tokens. So just put in, it's half of a cent for 1,000. You know what I mean? So in other words, if GPT-4 Turbo is too pricey for you, go back to the 3.5. Also, let me scroll down past all that. Image models, and I do want to generate an image for you, are basically 4 cents an image in standard definition and 8 cents an image in high def. But honestly, the high def doesn't really look that different to me. I think the standard definition is perfectly fine in most cases. I mean, you can experiment, but that's the price you're talking about. And for DALL-E 3, I would not use DALL-E 2 anymore. There's really no reason. For DALL-E 3, the resolution you'll get back is 1024 by 1024. I think it's like 1.5 million pixels, something like that, but it's 1024 by 1024. And you could resize it if you like or do whatever. That's what costs 4 cents an image. Now, the audio models, the Whisper model, the job of the Whisper model is to take audio and transcribe text out of it or to translate it to English. They only translate to English. They transcribe into many languages, from Hindi to Hindi, from many languages to many languages. But the translation is just to English. That is, you kind of see here, it's 0.6 of a penny per minute. So it's all based on how long the audio is that you're uploading. So it's not tokens anymore, it's minute based. And that's really all you need to know. I mean, if you go from there, if you need to know any more detail, then the page is here. I don't know if you bring up if they have an Indian version that would automatically convert to rupees or not, INR. But anyway, that's what we have. Now, let me move on. Okay, now, as far as when we're talking about a RESTful web service, you need 2 things. You need a JSON parser, okay? Some parser to create your records and to turn them into JSON and to deserialize JSON back into records and everything. And Spring, if you're using the Spring framework, comes with Jackson inside it. You can replace it with JSON if you want. It's up to you. I'm going to stick with Jackson. I'm going to go with that. But that means if I need to do any customization, then I use the Jackson annotations to do it. Okay, so that's what I will customize to that. Then I need to set up the networking somehow. Now, this is where Spring has changed rather significantly in the past couple of versions. 5 years ago, all we really had was the REST template. I use the REST template for everything. Methods like get for object or get for entity, post for location, whatever. And then eventually post for object. One thing to point out is in all of these tools, you're probably never going to need a put or a delete. It's all GET requests, and there's very few of those. The vast majority of them are POST requests. Okay, so you'll be using POST a lot. However, a few years ago in Spring, I think it was Spring 5, they introduced the web client. And the web client's the async one that's in the WebFlux module, so that your return types are then Flux and Mono. Rather than individual objects or collections, they're Flux or Mono. You're welcome to use that. One of my demos does. But what happened is over the years, people kept saying, look, REST template is so different from web client, and everybody's telling us to use web client even for synchronous things, and why do I have to deal with Flux and Mono if I don't need that? So finally, in Spring 6.1, which is basically last October, something like that, they finally came out with REST client. REST client has basically the same API as web client, but it's synchronous. And I expect that soon that will eliminate REST template. They still have not deprecated it, but sooner or later that's coming. Now, I want to talk about the fourth option too, which came in Spring 6.0, and that is HTTP exchange interfaces, because that turns out to be wonderful. But to start off with an example, let me go to my Git repository here, and let me make this full screen. So I'll give you the link to the Git repository. How's the font size? Do I need to go up another size? You okay with that? Okay, let me go to Mistral. And the nice thing about Mistral, you may have heard of Mistral. It's the French company. They have their own AI tool and everything. The nice thing about Mistral is they use the same API as OpenAI. So I'm going to show you a Mistral chat, but it's the same records for the input, the same records for the output as the regular GPT-4. Okay? Absolutely identical. In fact, if you go to Mistral and you look at the API page, they have a YAML document with the what we used to call Swagger, you know, the Open API document like that now, that's downloadable right from there. Okay, so what I'm going to do is I could list the models. Maybe I'll do that first. But you see what I have here is a REST client. And in a minute, when I move to the bigger ones, I'll auto-wire in the REST client. But right now, I think I do want to make that a little bigger here. I'm just going to use the create method to go to the base URL for the REST client, because it's simple enough to do that. So then I have my API key. Now, of course, I need a unique one for Mistral, for their credit, you know, to charge my credit card from them. And that is the normal practice. I set that as an environment variable so that it's accessible from system.getEnv. Now, when I move to the real one, or another one that uses more Spring features, I'm going to auto-wire that in with an @value annotation, because that's available too inside of Spring. But I just thought I'd keep it simple at the moment. So with the REST client, then all the HTTP verbs get their own method names. So this is going to be a GET request. There's the path, the part of the URI that comes after the base URL. And then you have to set various headers. And you always, on all of these tools, have to set an authorization header. And the authorization header always looks like bearer and then the API key inside it. It's a good idea to set an accept header and a content type header. Now, this is a GET request. I'm not sending anything, so I don't need a content type header. But the accept header says, yeah, I'm getting back JSON data. And I put in the string, but honestly, I could replace that with media type dot, you know, and get the right type there. Retrieve and then print out the model list. Now, what the model list looks like is this. Let's see if I can make it a little bigger here. This is a record called model list, which takes as an argument a list of model, if you will. And then model is right here. And see, I nested them because this looks just like the JSON data. Now, I don't have to do it this way, but it was easy to do it this way. I did make the attribute names match the properties in the JSON structure. Otherwise, I have to do more mapping. That's all. So my model record has an ID and a created and an owned by, and this owned by is the problem. Because, of course, in JSON data, they use lowercase with underscores, or what they like to call snake case, which is pretty funny. The one I liked, they called, when you have lowercase with dashes in between, that was referred to as, I heard that called train case, or even better as kebab case. That's pretty good. But if you have lowercase and are all uppercase, if the underscores are all uppercase, I heard that referred to as screaming snake case, which conjures up some weird images. At any rate, this is the problem, because I want to use camel case in Java. So I can either annotate the field directly with @JSON property, or this is available inside Spring as @JSON naming, and you put it on a class and you choose the snake case strategy, and then it will handle unfortunately, only that class. Like if I put it on model list, it would not translate to the inner ones. In Spring with POJOs, there's a property you could set in application.properties that converts automatically with snake case. It doesn't seem to work with records. I keep meaning to bring this up as an issue at Spring. So right at the moment, I put in the JSON naming, or I go right to the JSON property there. I did override the toString because I wanted to convert that Unix timestamp to dates and times. So if that's it, now I can just run this and we'll see what it looks like. Okay, it would help if I went to the test case rather than to trying to run that. So here's the one that lists the models, and let me execute that. And it's going to go grab that model, the response, which I didn't show you. Oh, you got to grab the model list, actually, and go down to the data part and turn it into a stream. And then I'll print them out with a peek method so we can see it. And then the ID is the name of the model. That's what I want. Convert it to a list. I verify that the ones I'm expecting are there. This is a common thing I do whenever I work with these things. I put in a bunch of constants for the model names to make sure they're working, just so I don't have to accidentally mistype something when I'm picking a model later. Whenever you're interacting with one of these models, one of these API tools, you're going to have to pick a model name. So I like that I can actually see what the model names are, and they're adding new ones all the time. I think this is a new one, the Open Mixtral 8x22B. The B in there is billion, and when they say 22B, that means 22 billion parameters, the weights in the model. That's the training data that you're downloading, or not the data, the training weights that you're downloading, the trained version. So the ones that are 7 billion are small models. 22 billion is basically a medium-sized model, and then there'll be like 70 or 80 billion, something like that, for the large ones. If you're running it locally with Ollama, that's got to fit into RAM. So it's a lot for that. But you see, there's the whole list of models that came out, and they have tiny, small, medium, large, an embed model, etc. Okay, so now that was simple enough, but what I want to show is that that's just using the REST client directly. Let me go to these HTTP exchange interfaces. So with that, I'm going to go to OpenAI, I think, and here is my OpenAI exchange interface. Every time I click, it's getting smaller again. Okay, you see that at the top, this is just a straight interface in Spring. At the top, I have an annotation that says HTTP exchange. That's like a common path that's going to be true for all of the individual methods. But you see now, all I have is an abstract method annotated with get exchange or post exchange. And I say what the rest of the path is, like models. And there I did convert the accept header into the media type constant, pulling it from there. But I'm not implementing that. See, I'm just declaring the method. What you have to do then is go to the config file. So this is a Spring Java config class. It's annotated with that configuration. And in here, you put together a bean to set up either the web client or the REST client. And I'll look at the REST client one. See, this is the @value annotation to grab the base URL, which is sitting in my application.properties file right now. And this is the @value annotation to get my key. And that, again, is coming from an environment variable. But I don't have to put either of them in here. They both are pulled in by Spring directly. Then I configure my builder with my headers. And that's all I have to do. But here's the beauty of it. I don't have to do that once, no matter how many methods I'm going to implement. So I set up the REST client. I set up the web client, and then down here, this is purely boilerplate. This is stuff that you copy and paste out of the Spring docs. I have to tell Spring, hey, that interface I made, the HTTP interface, I want you to implement it and give me an instance of it when I ask for it. So this is an @bean method. Create one. I gave it the name. I gave it a qualifier because I actually am using several web clients there. And then this stuff with the create and the HTTP service proxy factory, all that. It's the sort of thing non-Java people make fun of us for, right? But again, I just copy and paste. I have to change the interface being implemented, but it's a one-time thing and I'm done. Now I have an OpenAI interface that I can auto-wire in, and it doesn't matter how many methods I put inside this interface. I never have to touch that config file. I'm finished. So you can see what I have here is the models, and this one is for chat, where I had to create a chat request and return a chat response. Again, I put in the accept header in this case and the content type header. They're both JSON data. In this case, I'm sending in JSON and getting it back. And there's a different endpoint for that. Now for the chat request, there I have my record that has a string that tells me which model I'm requesting, a list of message and a temperature, and there's the message which has a role and a string content inside it. Now you may have noticed that role is normally a string. That's that user or assistant or system. I made it an enum just so I could be sure that I don't put in something that isn't valid. In fact, if I show you that real quick, there's the role, and notice the one thing I had to do to make the JSON parsing work. You see, in Java, that's a constant, so we use capital letters for everything. So here I had to put in this @JSON value method to say when they ask for it, convert it to lowercase. And here when I put it in, convert it back to uppercase when I need it. See what I mean? So I had to make some modifications so that in the enum, I can use the uppercase the way I want, but when it parses it, it converts it automatically. So going back to the interface and then back to the chat request here, there's also the chat response, which fortunately it's really unnecessarily complicated, but let me at least show you what's here. ID and object, I don't even really care about. What I care about is the answer, right? This is a chat. Well, the way they set it up, the response tells you which model they used. There's also the usage object to show you how many tokens you used. And then it's a list of choice. And down here, well, first of all, here's the usage with the prompt tokens, the completion tokens, the total. Notice how I use the JSON naming with the snake case strategy again. And then here is the choice, which has a message and a string. Pardon me, allergies. My wife always says, third one, you're on your own. I'm like, okay. It's funny, I don't know why. That's that same message from the input though. So what you have to do to get the answer out of it is you go to the response down here, you grab the first choice. Out of the choice, you grab the message, and out of the message, you grab the answer you want. And that's a pain, right? So this in Spring is why you make a service. So this is my service class, OpenAI service. And what you'll see if I go down to the constructor here is I'm auto-wiring in the interface. So that's that bean in the bean file. The mechanism, the pattern that I follow, again, this is my own opinion. So the others may have, reasonable people may differ, all that kind of stuff. I like to keep the interface as simple as possible. Here's the request object. Here's the response object. Just put it in once. Then I auto-wire that into a service, and I add a bunch of overloaded methods to say, well, if they want to specify just the input, I'll build it up. If they want to say the input and a temperature, I'll build it up. Put in a bunch of convenience methods for the user to create a request and convenience methods to extract the answer out of the response so that the user doesn't have to build the request by hand. I do generally put in the same method too, so if they want to build up a request and deal with the response, they can. But I do that. Now I'll get back to that wave file splitter in a minute. So here's the get chat response. This is the big one, well, one of the big ones, where I put in the model and a list of message and a temperature. I create the request myself. I get back the response. And you see how I dig through to go get the answer out of it, response.choices.getFirst.message.content. One subtle point here, get first. In Java 21, one of the specifications that they implemented in Java 21 was called sequenced collections. You probably won't even notice it. It's so minor until you start using Java 21. Basically, lists and sets and maps, they all have a get first and a get last and a set first and a set last, etc. So when I first wrote this, well, I'll show you. If I wrote it as get of 0, then I immediately get a little warning saying, hey, you know what? You could use get first instead, so I did. But if you run this in Java 17 and you get an error, just change it back to get of 0. Okay, that's all there is to it. And you see the rest of this is just overloads, just to make the process easier. Like if you just want to send a message, I'll delegate to that with defaults here. Or if you want to just put in the prompt or what have you, just a bunch of overloads on all of that. Now, if I go to my test class here, let me skip the models. And let's see, do I have any funny ones? Sort of, but I'll just keep it simple. This one's one of the big ones that I'm saying, according to Douglas Adams, what's the ultimate answer to the ultimate question? Well, I did that one yesterday, didn't I? Let's go with this one. How many roads must a man walk down before we can call him a man? Right? And I asked, I think I'm asking GPT-4 on that. Yeah, GPT-4 here. And the temperature I put really low, so I don't want a lot of randomness. I want a decent answer out of this. And whenever I've done this before, it gets the Bob Dylan reference, but it doesn't give me what I consider to be the right answer. And the right answer, you see, let me move this up, says the question is a famous line from Blowing in the Wind, blah, blah, blah. It gives me something, you know. It tries to take it seriously when it doesn't realize I was making a joke. You know, the one thing I have definitely learned, all these models, they have no sense of humor. I mean, and this is coming from somebody who tells dad jokes, and I don't think they have good sense of humor, you know? So at any rate, there's an example of how I can interact with that, and you saw that was all I had to do. Okay, so again, the process is the key here. The process is you want to model the input and model the output with records or nested records or something like that, because you've already got a two-string method. You already have an easy way to work in there. You got equals, hash code, all that stuff. Then you want to set up your networking, and I really like these HTTP exchange interfaces, especially if they have a common endpoint. You know, I'm just going to set up extra methods to do all of them like that. And then it's just a question of parsing the input and output. So I have to deal with the Jackson parser. That's the basic idea. Now, here's a neat factor that comes with Spring. And by the way, one of the last things I'm going to do is to show you that I put a controller on one of these and then compiled it with the Graal native image compiler, because why not, right? And that way it starts up in, you know, 1/10 of a second or something like that. Now, I didn't go to the trouble of trying to deploy it to the cloud or anything like that. I did, but then I ran into all kinds of problems. But at any rate, you see that the process will work. No, the part I like here that I didn't tell you about yet is validation. One of the, if you're accustomed to using Spring Boot, which I assume you are, then you know when you go to start.spring.io, you have all of these starters that you can use. And one of them is bean validation. Okay? Bean validation is the old Hibernate validator promoted to a spec, right? And that means you have all these annotations for validation. Well, I'm in a Spring app. There's no reason I can't just use those directly on my records. So let me skip to one where I actually show that. We've already covered all of this. That was listing the models and using the records. And I want to skip to, that's a service class. Again, all this is in there, so I'll wind up giving Dilip or whoever the slides, and then you can take a look at that. It's when I generate audio from text. That's the one where I want to show you an example here. So in fact, I'll just go right over here and bring up my text-to-speech service, which has as an argument a text-to-speech request that I made. So let me grab that. And now let me make that bigger. And Do you see what I've done in the record? I have sprinkled throughout the validation annotations. The pattern annotation, for example, comes from jakarta.validation.constraints. And I just put in a regular expression saying look, it's either TTS1 or it's TTS1 HD. And that way I can check the pattern. And that the input, according to the documentation, can't be blank and has to be a maximum size of 4K in terms of text. And voice, I wound up making an enum out of because there were only 6 choices, so I figured that was easier. Response format, I also made an enum, but this time, rather than trying to put some JSON naming one, this was a perfect use case for just the JSON property. Just say, look, this is how to convert the camel case to the snake case, and that's easy to do. And on the speed, I put in a decimal min and a decimal max, and now I've used all of those validation constraints. Now, the one downside is it doesn't validate automatically. You have to call the validator to do it, okay? Now, one thing that's different, if you don't want to use the validation constraints, is you can do this. And I mentioned this yesterday, but a lot of Java developers are not aware of this. Records are allowed to have inside them what they call a compact constructor. A compact constructor, I hesitate to call it a constructor because you know it doesn't have any parentheses on it. It's the same name as the class, but no parens. And inside that constructor, you do either transformation or validation or both. So here I'm doing stuff like saying, look, if the model's null, I'll pick one. That way you don't even throw an exception. If the response format is null, I'll use MP3, which is what I want. But see, this allows me, now this is redundant, obviously I had the other ones at the top, but I could do it this way instead. If the speed is less than 0.25 or greater than 4, throw an illegal argument exception with a message, and that's fine. I also generally add additional constructors to my records so that they'll set the defaults to things I don't feel like specifying. The rule in records is any additional constructors must delegate to the canonical one. So they all have to call this with whatever the arguments are going to be. So you see how this works. Now, what about the validation? If I go back to the text-to-speech service here, what I do after auto-wiring that in, right inside there, is I also auto-wired in a validator. Now, I got to warn you about validator. Spring makes use of so many third-party libraries that if you just put validator and hit Control space, I mean, I'm only seeing 1, 2, 3 of them right now, but believe me, there are about 6 in the class path. Make sure you get the right one. The one from jakarta.validation.validator. So I just have to make sure I do that, and that's an interface. So it's wiring in an implementation of it, and I don't care what the implementation is. So I plug that into the constructor, and whenever I get a request to convert, then I deliberately call validate request. Now that method is down at the bottom here. All I do is I call validate on the validator with the request, and that returns this strange thing, a set of constraint violations. And I say if it's not empty, then I'll rethrow it as a constraint violation exception. You can handle it however you think best. Something like that. So that's how I make sure the validation happens. Now on this particular one, what's interesting about the audio one is that there's no output to worry about in terms of a JSON object. Remember, you have to model the input and model the output. In this particular case, if you set, in the TTS request, if I set this response format to a particular property, then rather than giving me a JSON object, it'll give me the MP3 directly. It'll give me the byte array right out of it, which is what I want, because then I can just save it to a file or play it directly. So when I invoke this thing, let me go over to my, my test here. Then what I do is I just say, get the audio prompt, and in my background, actually you don't see it, it's one of the built-in ones, is I say I want back that binary JSON stuff. I want the byte array inside there. Now actually that one I should go back to the interface, because here is the text-to-speech one. There's the endpoint. Notice it's a post request, audio/speech. The accept header I had to set to audio MPEG. Now, some of them accept a return type of audio/star or whatever. This one, I knew I wanted an MPEG back. I set it to that. So just to make sure. And of course, the content type I am setting in application/JSON. And you see the return type on the method is just a byte array. I'm done. See, that's why I like this HTTP Exchange interface approach. So if I go to the test this time, the only thing I'm going to do is try to do what I wasn't able to do yesterday, is I'm actually going to invoke this and run it through an online. I found a class that plays MPEGs in Java. So I'm going to generate the audio and then play it all in one step. So I think this is the one, and it's going to pick a random voice out of the 6 that are available. So it's going to send the request, get back the byte array. You know, it cost me 0.6 of a cent or something, maybe 1/10 of a cent. Yeah, see, it told me which voice it's using, the Alloy one.
Tales from the Jar side is your best source for learning about Java, Spring, and other open source technologies.
Marketing,
especially when combined with AI tools. The companion newsletter of the same name is also a lot of fun.
At least I hope so. But you see how that worked? And it's all the codes in the GitHub repository. You're welcome to it. I put in a MIT license or something. I also put in a sample that had some technical words in it, because you never know how it's going to handle the technical words. And I'll just tell you that the only thing I had to do is I had to put a dash in JUnit because it kept pronouncing it as Junit. I'm like, no. And that's the problem with the audio one, is that it's nothing you could tune. You can't fix it. You can't pick your own voice. There's 6 choices and that's it. I'm sure there are going to be other libraries that'll give you a lot more flexibility, but that's something you could use right away. And you see, this was a really easy one to pull off. In fact, I think this one may be the easiest of them all. Okay. Now, let me show you something image related. Again, in the slides, I have the curl request. You can see what it looks like. See how simple this one is for the audio? Really easy there. And I'll skip the information about it. Right. And then try it out. There's the location of the MP3 player in case you decide you want to play with that. Thank goodness for backward compatibility in Java, right? I think that MP3 player came out in like 2008 or 9, something like that, and it still worked. And I was running on Java 21. It's like, oh, cool, okay. But again, add the method to the service. I just instantiate the player class, put in a buffered response, and just play it. And then I told you about the validation. So that's in the slides too. And yeah, here I could add a controller as well. You know what I mean? Yeah, we're still doing fine on time, but maybe I'll show you that now. Not that I want to do the controller part, but I want to show you how I can do the native image one. Okay, the Graal native image stuff. So what I added here was a controller called, let's see, OpenAI client. This is my text-to-speech controller. Make that a little bit bigger. And it's really simple. It's a REST controller with a post mapping to TTS or TTS/play, TTS for text-to-speech. And of course, I auto-wired in the service, you know. So I put in the response body a string text and say, go ahead and generate it and say it's converted to MP3, or I could play it. And if you're an IntelliJ user, which I imagine many of you are, if you go under the little thing that looks like a planet next to it here and just say, create a request in the HTTP client, then I could just edit it right here, but I think I already have one. Let me scroll up here to, yeah, here it is. I keep trying to do that. So this one does a post to localhost 8080/TTS. There's my accept header, there's my content type, and then, you know, I put in my block here. And this would work if I just ran it normally, just ran the application. But since what you're probably interested in is the Graal part, let me show you that in the build file, at the top, what I have added is the Graal native image tool as the plugin. because it turns out that's all you have to do in Spring. Just add the plugin inside your Gradle build file. I don't remember what the analogous thing is in Maven, but just go to start.spring.io and add the Grawl starter, and you'll see it. You know, they'll plug it in right in for you. That's how I found out what this was. And you see, basically in here, everything else is the same. I needed that separate repository because that's where I found the audio player that I was telling you about. But, you know, I've got the web starter, the web flux starter, the validation starter. There's the audio player. I've got the test starter, a reactor test, this little quirky, stupid thing you have to do for Macs when you use WebFlux to make the warnings go away. You know, that's all that is. And that's it. That's the whole builder. What that means is, though, is if I look at my Gradle build, then there's actually a mechanism called native compile built right in. And I could run it from here, but what I'll do is I'll run it from the command line and say .gradle w native compile and hit enter. And it takes a minute, you know, to build the whole thing up. But what it's doing is it's, for those who are not aware, it is compiling it down to machine language for the platform you're on. And I'm on an M1 Mac. That's what I have here. It's an M1 Mac. That's why I kept having trouble deploying to the cloud, because I kept getting errors like, no, it has to be AMD or something. I mean, you know, it reminds you why Java being write once, run anywhere was so attractive in the first place. It's like, oh yeah, now I'm locked into a platform and I have to figure out how to deploy that. But it's cranking away and it's doing whatever optimization it does. And I don't really know the details of that. I'm sure there's people here who know way more about it than I do. But it was easy enough to use. And when that finishes, what you wind up with is a native executable that is big, by the way. I mean, this tiny little app, I've got a few services and a couple of controllers and everything, is about 100 megs in size for the executable. But the startup time, I mean, if it's a half second, that's slow. If it's a tenth of a second, that's probably closer. You know, maybe the first time it might be slower than that, but the second time, it's blisteringly fast. So what it's for is if what you're doing is stateless, right? If what you're doing is a function as a service or whatever. I don't know if you heard, I did the stateless service joke before at the keynote. Let me do that again. I say to you, I think all services should be stateless. At which point you go, really? Why do you think that? And I say, why do I think what? Yeah. So at any rate, there it is. It completed. It said it's written to build/native/native compile. So if I look in that directory, native/native compile, you can see this OpenAI client. The name of the project is 102 megs. But if I just give it a path to that, build/native/native compile/OpenAI client, then again, this is the first time. Yeah, it started already. 0.079 seconds, you know, 0.08 of a second. Sorry, something like that. Now, this is a small app. And again, suddenly I have deployment problems because I'm compiled for my M1 Mac, that particular architecture. But that means I can go back to that generated request here and say, you know, subscribe to Tales from the Jar side. Well, I'll run that post request. And now that my server's running, there, it sent it already, and I got back a response already. And I think I say in the run window, I think you see it at the bottom. Yeah, I don't know, but I could play it for you, but you get the idea. You know, it ran just fine. Everything works okay. And I do recommend that. And again, this is something I assume the frameworks will offer sooner or later. But you can do that tomorrow. I mean, that's the thing. You hear all these marketing people saying, oh, this is going to change the world and this is going to be phenomenal and all that. And my attitude is, look, I'm just going to focus on what I can do today. There's a lot of hype in this industry, and I have no idea what's going to happen in the next year. But I know what I can do now, and that's what I want to show you. And then you can, hey, if it changes tomorrow, I'll add more, you know? Okay, the last one I was going to show you, because we're going till 20 after, is that right? So I still got 10 minutes. Yeah, all right. Then let me show you, oh yeah, that's the slide, by the way, about the Grawl native image controller. To just use the native compile task, and I already did the stateless services joke. You see, it's a problem with doing a bunch of talks. They know all my gags. It's a problem. What are you going to do? But all right. I'm going to talk to you a little bit about the image generation stuff. And then maybe I'll use a different service, you know, because there's plenty of them out there. The image generation was with DALL-E 3. So in fact, let me go back and show you that. And here is, that's Anthropic, that's Mistral, that's Gemini. Oh, here it is back here. So this is platform.openai.com. And if I go to the image generation one, then once again, I always go to the curl request. And from the curl request, you know what the input looks like. So again, there's an endpoint that ends in images/generations. You put in your JSON header, you put in your content type header and your authorization header, and the prompt just has a model, a prompt, a number, and a size. Now, this is what's changed over time. With DALL-E 2, you could generate as many as 10 images at a time. They charge you for them all, but you could do 10 of them at a time. With DALL-E 3, one at a time. That's it, just one. So in fact, in my authorization, I make sure I say, oh, if this is a perfect example of doing the compact constructor inside a record, because I can actually write the code to say, if they chose DALL-E 3, then n must be 1. Something like that. See, that would be hard to do with annotations, but easy to do that way. And then the response that comes back, I have to go to the API reference to see that. And here on the images, again, the plan is you send in a prompt and a model, and n, and you can put in other things like, is it high def or not? But here's the key property for me, the response format. Can you see that more or less? It's either URL, which is the default, or B64 JSON, base 64 JSON encoded string. Say it differently, base 64 encoded JSON string, right, up there. If you do URL, you get back a single JSON object with a URL property, and then you have to go download the image. And you don't have a lot of time to go download the image. And I'm like, why do that? If I set it to B64 JSON, I get back the base 64 encoded image directly. And then what I do is when I save it to a file, then I convert it. So if I go to my DALL-E service. So again, I'm auto-wiring in that OpenAI interface. So the OpenAI interface for images is, again, I'm putting in JSON, getting back JSON. I have to make an image request to get back an image response. And if I go to the service now, the DALL-E service, I've auto-wired it into here. And I say, okay, here's the big one where I put in all the separate fields and create an image request, and then I delegate it to the interface method. Here, send this request, get back the response as an image response, and then when I actually call it here, I have this method. Let me just show you that method very quickly. Write image to file, and what I want to show you here is this guy. Can you see that? Java has a class called java.util.base64. You call get decoder, you decode the image, and you're done. I mean, how nice is that? See? So now if I go to the test, because I do have time to generate an image for you, and let's see if I got a good one. Here we go. This time I'll do the cats playing gin rummy. I'll use because dogs playing poker. That's a cliche. I was on a plane a couple weeks ago to go to a conference, and my wife was coming with me, so I was using ChatGPT on my phone, and I did cats playing gin rummy and horses playing Texas Hold'em and giraffes playing, what were they playing? I don't remember, but I did a whole series of animals playing casino games, and it kept her entertained. That was the whole goal here. Anyway, let me run this. Yeah, that's the right one. Okay, let me run it. And then see if we get a good cat picture, because, I mean, after all, that's what the internet's for, right? Now, what I've also played with, and you'll find in the repository, is Stable Diffusion, which changed dramatically between version 1 and version 2. In version 1, they had a very special mechanism. In version 2, now it looks a lot like the others. It's a lot cleaner here. Yeah, that sent the request. Now I'm waiting for the response to come back. I also have used, well, not just Claude. Gemini has an incredibly large context window. You have as much, Gemini 1.5 Pro has a million tokens in the context window. And you'll hear people talking about RAG and everything. I uploaded my entire Help Your Boss Help You book into the context window and said, give me the top 5 points from the book or whatever. And it was fine with it. It took less than 100,000 tokens to do it, you know? Okay, so that wrote the image to the disk. Let me show you the image and let's hope that came out nice. So here is, that's the audio one, and 2024, I think that's the one. Yeah, okay. I mean, it's cats, and I assume they're playing gin rummy. Funny how the cards are mostly face down, and that's in your favor, because that's where the image and stuff looks really weird, you know? But, you know, hey, I call that a win. You know, put that in the win column there. So let me at least let you know that, let me move on. Again, all that stuff I was telling you about is in the slides. Oh, I have a playlist of all this stuff, but I wanted to tell you also, I mean, I played with Gemini, I played with Stable Diffusion. What didn't I mention? There was something I was playing with lately. Okay, let me be clear. Did I take the slide out? I did. I don't have them here. If you want to do RAG, if you actually do want to do retrieval augmented generation, I don't do that by hand. The endpoints are available, obviously, inside there. If you're not familiar with RAG, I can summarize it in a minute. The idea is, hey, I don't want to put my whole book in the context window, because even if it fit, that's a lot of tokens and they charge by the token. You know, I don't want to pay a whole $1 for a request, something like that. So you run it through what they call an embedding algorithm. So what it does is it takes the text and it converts it to a vector. If you have a math background, it's just a vector in some high dimensional space, bunch of doubles, okay? Saves the vector in a vector database. Then whenever you make a request, hey, here's the question I want you to answer, it does the same algorithm, convert it to a vector, and then on those vector databases, they all have what they call a similarity search. Show me the vectors in the database that are closest to the vector of my question. It extracts those from the vector database as the actual context, puts it in the context of your request, and submits that. That's it. All you're doing is saying, instead of submitting the entire document that my company provided, I'm only going to submit the parts of that document that are most closely related to the question I'm asking. Now, back when we had a 2K context window, that was really important. I mean, 2K is not a lot. I remember back when we had, you know, limited amount of RAM on the machine and you had to pick what to fit into RAM. Now you just buy RAM, you know, whatever you need. But for this, it's the same idea. We want to filter it down to just the relevant parts. But you can see there's lots of decisions to make. You know, what vector database do I use? What embedding algorithm, which is an encoding? What do I want for there? How do I set all this up to make sure that I add it? And then, oh, by the way, I got to take the answer out and turn it into a context message. That's a system message that you put inside the chat. You got to do all these different things, and it's one of those things that I refer to as dangerously confusing. You could spend, everybody in this room could spend an hour on it, and you'd understand it. You might not know all the options and all the details, but you'd figure it out. It's not that bad, and it's the same every time. But then you'd have all these choices, and then you'd have to. The reason I call it dangerous is because everybody who figures it out then figures they have to go tell everybody about it, and you get tired of hearing about it from another video and another person, but that's a different problem. Here's the thing, let the frameworks do that for you. LangChain4j and Spring AI both have the RAG capability built in. In fact, LangChain4j will say, tell us what directory your files are in. That's another thing I left out. You have to have what they call a loader for the files themselves. And it could be PDFs, it could be spreadsheets, it could be Word documents, it could be pretty much anything. And you have to pick a loader. By the way, if you're looking for a loader, they have one from Apache Tika, Tika. That's a really good project for loading data from almost anything, especially PDF and Word documents and spreadsheets and all kinds of stuff. Really, really good for that. At any rate, they're all built into the framework. You just say the framework, yeah, don't bother me. Just tell me the defaults, pick a directory. Here's where the files are. Pick an encoder so I don't have to deal with it. And then you could just ask it questions, and it works just fine. So the things I do with the framework, I do that with a framework, anything related to RAG, just hoping that the things don't change too dramatically in the next 6 months for those frameworks, you know. And is there anything else I do with the framework? Fine-tuning, embedding, things like that. Yeah, it's not worth it to write it by hand. Making a custom GPT, OpenAI has this assistance API that lets you make the GPT by hand. Yeah, it's not worth it to do it by hand. Let the framework do it. In fact, write the code the way I wrote it. I mean, that's what you're doing, right? You're basically making your own app that works just fine, which you could deploy anywhere. So to summarize, I think the HTTP Exchange interfaces in Spring are awesome, but you can use the REST client directly or whatever you like. The Java config makes it easy to set up. You auto-wire the interface into a service so you can make it easier on the user to do the input and the output. Get to know the Jackson JSON parsing, because that I didn't show you, but sometimes they use like multi-part file or upload type things. And fortunately, Spring's got constants for that too. You know, so you can do all that stuff as well. You can always add a controller, but I recommend doing it as a service so you could test it. Then you could always plug the service into a controller and try it out, and you've still got the Graal native image compiler. I've only done it on simple cases, but it's worked just fine for me so far. If you do decide to go to the frameworks, then I would seriously suggest that LangChain for J is a good 6 months ahead of Spring AI, but give them both 6 months and they'll both be 1.0, they'll both be fine. Okay, I think I've used up my time. I'll hang out for a few minutes if you want, but thank you very much for coming. Oh, I didn't. My apologies, I didn't give you the GitHub repository. So let me just add that in here. Whoops. Oh, great. I think I hit the wrong button here. GitHub / my last name / OpenAI client here. And you'll see it from there. It says OpenAI client under my last name at GitHub. Okay, thank you.